Hi, good morning, everyone. This is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. And today, in this episode, we are going to discuss about the neural networks. So already we have discussed so many topics in the artificial intelligence and machine learning video lecture series. So here, in this unit, that is the fundamentals of machine learning, we are going to discuss about the neural networks as a next episode. Okay, come, let's get into the topic. So the neural networks, actually, the artificial neural network that is usually called as ANN or simulated neural network that is SNN or a subset of machine learning or at the heart of the deep learning algorithm. Their name and structure are inspired by the human brain, mimicking the way that biological neurons signal to one another. So working method, ANN are comprised of node layers, an input layer or one or more hidden layer and output layer. So this is the structure. And each node or artificial neuron connects to the different to the another and has an associated weight and threshold. If the output of the any individual nodes is the above and specified threshold value, the node is activated, sending the data to the layer of the network. Otherwise, the node data is passed along to the next layer of the network. So neural network rely on training data to learn and improve their accuracy over time. However, once these learning algorithms are fine-tuned for accuracy, they are powerful tools in computer science and artificial intelligence, allowing us to classify and cluster data at a high velocity. Tasks in speech recognition or image recognition can take minutes versus hours when compared to the manual identification by human experts. One of the most well-known neural network is Google's search algorithm. So how do neural networks work? Think of each individual nodes as its own linear regression model composed of input data, weights, a bias or threshold, and an output. So here we have given that is summation Wixi plus bias, which is nothing but W1 x1 plus W2 x2 and W3 x3 plus bias. So from that output f of x, if it is, for one there is a condition, and for the zero there is a second condition is there. So likewise, the neural networks works accordingly. Once an input layer is determined, weights are assigned. These weights help determine the importance of a given variable, with large ones contributing more significantly to the output compared to the input. All inputs are then multiplied by their respective weights and then summed. Afterward, the output is passed through a activation function which determines the output. If that output exceeds a given threshold, it fires. That means activates the nodes, passing data to the next layer in the network. This results in the output of the one node becoming in the input of the next node. The process of passing data from one layer to the next layer defines this neural network as a feed forward network. So let us break down what on single node might look like using binary values. So for surfing, s equal to 1 and no is which is equal to 0. We will be take like this. So the decision to go or not to go is our predicted outcome or y head. So let us assume that there are three factors influencing your decision making. Are the waves good? Yes or no? That is the 1 or 0. Is the lineup empty? 1 or 0. Has there been a recent shark attack? 0 and 1. So then let us assume the following inputs. X1 equal to 1 since the waves are pumpy. X2 equal to 0 since the crowds are out. X3 equal to 1 since there has not been a recent shark attack. So now we need to assign some weights to determine importance. Large weights significantly the particularly variable are of greater importance to the decisions or outcome. So here W1, W2, W3 the values are given and the appropriate outcomes which is mentioned over here. Finally, we will also assume the threshold value of 3, which would translate to a bias value of 3 with all various inputs. We can start to plug in values into the formula to get the desired output. So that is y hat equal to 1 into 5 plus 0 into 2 plus 1 into 4 minus 3 equal to 6. So if we use the activation function from the beginning of this section, we can determine that the output of this node would be 1 since 6 is greater than 0. In this instance, you would go to the surfing. So here in this, there's an example above. That is, we used perceptrons to illustrate some of the mathematics at play here. But neural networks leverage sigmoid neurons, which are distinguished by having values 0 and 1. So these neural networks will actually resemble like your human, brain activity. So actually, this will so the large number of data sets will give the more accurate value. So when it is considered for the large amount of data sets, and here I represents in this term, I represents the index of the sample, and y height is the predicted outcome, y is the actual value, m is the number of samples. So this is the cost function, the term. So let's take the classroom activity. So this is from the given image, you have to identify the word and expression for the given image. And cost function, which is given over here, that is a starting point and loss and value of weight. So point of convergence, it is where the cost function is at its minimum. So this is the cost function. So the neural network types. So there are several types of neural networks. One is feed-forward neural network or multi-layered perspectron. Then convolution neural network (CNN) and recurrent neural networks. So neural network learning process, here there is a forward propagation and here there is backward propagation. So forward propagation, which is nothing but of a from the data, that is a x1, x2, like that. We have several data are there. So prediction y, then true value that will be compared to the loss function, then loss score and optimizer, then weight update, then finally weight. So this is called a back propagation. This is the forward propagation. Then iterative process until loss function is minimized. So this is the neural network learning process. So this is a neural network trained CN, convolutional neural network. So this input data and adjusted weights and biases, and forward. This is the backward propagation and actual value, targeted value, then loss function. So this is the best example for the neural network. So the applications of neural network, it is used in aerospace, defense, facial recognition, healthcare, stock market prediction, signature verification and handwriting analysis, social media, weather forecasting, etc. So there are so many applications are there for neural networks. So let's have the assessment. So the very first question is explain about biological neuron. Why we are giving this question is we have to understand the first biological neuron, human neuron systems. Then only we can able to understand the that is a neural network, convolutional neural network, by comparing biological neuron with this concept. Then it will be easier to understand the concept. So that's why this is the question, assessment question. The next question is describe about artificial neuron. Then third question, explain about the characteristics of artificial neural network. Thank you.